Welcome back. This is lesson 3-2, finding slope. This is our second lesson in the unit dealing with linear equations. Slope is one of the things you're going to see come up all the time over the next couple chapters. So it's a really important topic, so I really hope you pay attention and you kind of start to understand what exactly is slope. How do I figure out slope? How do I calculate it? Because we can calculate it a bunch of different ways. But first thing we need to know is what exactly is slope. Slope is the amount of turn in a line. It is how much or how quickly a line increases. Here's a couple different types of slopes we can have. When we talk about positive or negative slopes, it kind of deals with how the line moves as we move from left to right. A positive slope increases from left to right, or it just goes up as we move further right. A negative slope decreases or goes down as we move from left to right. A zero slope is a horizontal line. So if the line is just a straight horizontal line, it actually has a slope of 0. And then a slope that is straight up is undefined. In a later video, we'll talk about what an undefined slope is, why it's undefined. But for now, just know that if you see a vertical line, you don't even have to do anything. Your slope is undefined. That's what we write the answer as. And there's a few different ways we can actually calculate slope. The first one is using rise over run. Okay, when we use rise over run, first thing we do is we pick 2 points on the line. We want to pick spots where the two crosshairs of the graph come together. So when your X and your Y lines come together in a perfect spot, like we have right here. Okay, that's our first point. Second point, I always try to look at the X and Y axis and see if there's one where it crosses, because a lot of times that's an easy spot to find one. And I see where it crosses right there. So the first thing we do is we count our rise from one point to the other. It doesn't matter whether which point I start with. I'm going to start with this left point. First off, I look at the line and I see it's increasing as it goes from left to right, so it's a positive slope, right? And then I count my points. 1, 3, 4, 5, 6, 7. And I want to stop when I'm in line with that other point. Let me try and recount that. I just want to make sure I counted that properly. 1, 2, 3, 4, 5, 6, 7. So my rise equals 7. My run is how far I go left or right to get from one point to another. So right from where I left off, I count 1, 2, 3, 4 spaces. So my run is 4. Okay, I can actually write slope as the rise over the run. So that means this is 7 over 4. So my slope for this line is actually 7/4. Now, when I give slope as an answer, I can leave it in 2 ways. First way is as a slope, 7 over 4, and that's the way we're going to see it most often. But sometimes they want you to turn it into a decimal, so you would actually have to do 7 divided by 4, drop the 7 in the house, and do your division. Put in my decimal point, put in a 0, and keep dividing until I have no remainder. In this case, it would be 1.75. The variable we use to show slope is m. So we would say that m is equal to 7 over 4, or m is equal to 1.75. Both of these show the slope. Pause the video, take a second, do the next 3 problems in your notes, come back, check your answers with mine. So in these 3 problems, they actually give us the points that we're going to use. So we just count our rise and our run. We look at the line and see if it's got a positive or a negative slope, or a slope of 0, whatever it is. And then we rewrite it as rise over run. So in this first one, our rise from one point to the other is 1, 2, 3, 4. It's 4 spaces. And our run is just 1. So we say our slope is 4 over 1, or just 4. Okay, and because it's increasing as we move from left to right, as I go from left to right, my line increases. That means my slope is positive. My second one, as I go from left to right, my line is actually decreasing. So I know I'm going to have a negative slope. So I'll just write negative right now. I do my rise. 1, 2. My run is also 1, 2. It's negative 2 over 2, which if I divide, 2 divided by 2 is negative 1. My last line, as I go from left to right, it's increasing, not by a lot, but it is increasing. My rise is just one box up, and then 1, 2, 3, 4, 5, 6, 7 over. So my slope is 1/7. Again, these graphs are a little bit bigger on your paper, a little easier to see, a little easier to trace. And then if I wanted to figure it out, I could actually do 1 divided by 7, which I just plugged into my calculator, and it's a long decimal. We can round it to about 0.143. Okay, so that's finding slope using rise over run. If you're given a graph, this is always the easiest method to figure out the slope. Count how much from one point to another we rise, how much we run, simplify if we need to, and that'll tell us what our slope is. Again, as we move from left to right, if the line increases, meaning goes up, we have a positive slope. If it's decreasing, we have a negative slope. We have a few other pieces of information we would like to talk about. One thing is the larger the slope, the steeper the line. So as your number increases, this is a line with a slope of 0, this first one. And as the number gets bigger and bigger and bigger, your slope actually goes higher and higher and higher. Therefore, if you have a very steep line and you find the slope is very small, you should probably check your work again because it's probably not the correct answer. Okay, moving on, we actually are also able to find a slope when given 2 points. For example, we have this, well, not for example, we have this formula. This is our formula for slope, y2 minus y1 over x2 minus x1. And if we have 2 points, we can figure out the slope of any line that connects these points by plugging the numbers into this formula. And it'll tell me what my slope is. Okay, I have 3 steps here. First step is I pick my 2 points. Sometimes they're given to us, sometimes we can pick them. We want to label our points, which one is x1 and y1, which is x2 and y2, and then plug them into the formula. It's a lot easier to see when we actually go through a sample problem. So let's look at one. It says find the slope of the line that goes to the point 6, 2 and -3, -1. So we want to first, I'm going to rewrite our formula. So the first thing we want to do is take our 2 points. And we want to figure out which one's my first point and which one is my second point. And it doesn't matter which one you pick as the first point or the second point. So I'm going to pick this one as my first point, which means this is my x1, this is my y1, this is my x2, this is my y2. Okay. Now I'm just going to take these numbers and plug them directly into my formula. y2 is -1 minus y1, which is 2, over x2, which is -3, minus 6. Then I'm just going to solve. -1 minus 2 is the same as -1 plus -2, which is -3. -3 minus 6 is the same thing as -3 plus -6, which is -9. A negative divided by a negative is a positive, so my slope is a positive. And I can simplify 3/9 to 1/3. So my slope for these 2 lines is 1/3. It's important to know that anytime you have 2 negatives like you do here, that's going to end up being a positive because a negative and a negative is a positive. Pause the video. Try this same formula for the next 3 problems, then come back. So, we have 3 different lines here with points. Remember, I'm going to rewrite my formula up in the top so that I always have access to it. y2 minus y1 over x2 minus x1. First thing I do is pick which point is 1 and 2. So I'm going to call this one x1, y1, this one x2, y2. Now I'm going to plug my information in. Y2 minus y1 over x2 minus x1. 2 minus 1 is 1. 9 minus 3 is 6. Therefore, my slope is 1/6. Again, I could turn it into a decimal by doing 1 divided by 6. But for now, I'm going to leave my answer in terms of a fraction. Second example. I always just call the first point 0.1, the second point 0.2, because it doesn't matter which one, and it's just easier for me to see. So I'm going to call this one x1, y1, and this one x2, y2. Okay, so I plug into my formula. y2, negative 1, minus negative 4, over 3, minus negative 2. Remember, anytime we have two negatives next to each other, we subtract the negative, they both become positive. So this is negative 1 plus positive 4, which is positive 3. These are, again, two negatives. They both become positive, so that's 3 plus 2, which is 5. My slope is 3/5. And my third example, I'm calling this point 1 and this point 2. Plugging the information into my formula. y2 is negative 7 minus y1, which is 2, over negative 2 minus 7. Negative 7, take away 2 more is negative 9. Negative 2, take away 7 more is also negative 9. Negative 9 divided by negative 9 is positive 1. So my slope for the third one is positive 1. So that's how, given 2 points, we can find the slope. In the first section, we found the slope using a graph. The last way I want to talk about is using a table. So we're going to find the slope using a table. All the table, again, is a bunch of ordered pairs. Okay, slope is known as what is known as a rate of change. Okay, so we want to figure out the change from one point to another, and these are all just x, y pairs. So this first point is 345. The second point is 575, and the third point is 135. I can pick any 2 points, which means it makes sense to pick the 2 easier ones. I'm going to call this point 1 my x1, my y1, this point 2 my x2, y2. And I'm going to plug that information now into my slope formula. So y2, which is 75, minus y1, which is 45, over x2, which is 5, minus x1, which is 3. I subtract. 75 minus 45 is 30. 5 minus 3 is 2. Then I can actually do 30 divided by 2, or cut 30 in half, and that is 15. So my slope, m, for this table is 15. So if we just recognize that all a table is a group of ordered pairs arranged in a different way, just like a graph, then it's pretty easy to figure out the slope when given a table. So, like I said previously, slope is what is known as a rate of change. The slope is only there if the rate of change is constant. So, there are times when we figure out our slope and we see that the slope is not the same for 2 different points. That would mean that we have a variable rate of change. Okay? If we have a variable rate of change, there is no slope of the line, because it's not actually a straight line. So let's take a look, for example, the first one. Okay, I have the points 0 or 2, 3, 5, 6, and 9, 9. So if I were to do the slope using these 2 points, I would have y2 minus y1 over x2 minus x1. 6 minus 3 is 3. 5 minus 2 is also 3. So I get 3 over 3. I get 1 as my slope. But if I were to pick the other 2 points, so let's just keep that 1 off to the side. I'm going to erase a little bit. And let's just use the other 2 points instead. We'll call this x1, this y1, this x2, that y2. And I just plug in y2 is 9 minus y1, which is 6, over x2 minus x1. And I solve. 9 minus 6 is 3. 9 minus 5 is 4. This time I have a slope of 3/4. These do not match. They're not equal. So what we say is we have a variable rate of change, which means there is no slope. Because in order for there to be a slope, they would all have to have the same rate of change. For example, my second one. This is the same problem we were just looking at. We figured this out to be 15. So if we were to use the next 2 points, 5, 75, this point, and 9, 135, this point, we should still end up with 15 as my answer. So let's do that. 135 minus 75 over 9 minus 5, or y2 minus y1, x2 minus x1. 135 minus 75 is 60. 9 minus 5 is 4, and 60 divided by 4 is 15. So it checks out that no matter which of the points I pick, I have a constant slope, and that slope is 15. So slope, rate of change are similar. In order for there to be a slope, the rate of change has to be constant. So no matter what 2 points I pick in my chart, I should have the same slope. And that's because, as we showed in the line is constant. The line increases by the same amount. That means at every point, the slope will be the same. Okay, so hopefully we learned finding slope using a graph, finding slope using a table, finding slope using 2 points. Slope is an important thing. We're going to spend a lot more time talking about it than just on this video, but hopefully this is a great introduction. Hopefully you saw the many different ways you can find slope depending on what we're given. Hopefully you followed along the notes and you really paid attention, because slope's going to be so important moving forward with linear equations and systems of linear equations. So again, if you have any questions, please contact me, leave a comment. If you don't have these notes, they're available in my Teacher Pay Teacher store that go along with these videos. They're great to have. So leave a comment, email me, do whatever you have to do.